Hi everybody, Luke Gallant here from the YT624EJ maintenance channel. So we're moving on to episode 22, and this episode is not one of my favorites because it's the first time I have to fix this snowblower. Almost, I might have had to fix it once before, but I've never ever had a reliability issue with this blower until yesterday. Luckily it wasn't me, it was my dad that had it. But anyway, I had kind of seen it coming. In my last episode, you'd seen that sometimes when the chute would try to go right, it wouldn't do anything. And now we're into permanent failure mode on that. I'm gonna show you what that is here. So with the key on, if we put the chute to the left, you could tell that it wants to move, but it's all the way at the end. Whereas if we wanna go to the right, the switch kind of doesn't click there, and the chute doesn't move to the right. So episode 17 is when we worked on the switch. And what I'm gonna do now is go from the 7-minute and 55-second point in that video, and I'm gonna take the multimeter underneath and try the switch left and then right. So I'm gonna unplug the switch and I'm gonna use the wiring diagram from the 7-minute 55-second mark in the video, episode 17, and I'm gonna look for continuity exactly how it's described there, and I'm gonna see if it works on the left, I'm gonna see if it works on the right. So I'm gonna video that, and then once I hopefully confirm that it doesn't work to the right, or at least one of the contacts doesn't work to the right, I'm going to take this this cover off, and I'm going to get the switch out. I'm going to skip all that because it's in episode 17 already. Then I'm going to open the switch up in the vise and see what we've got going on. We had about 12 inches of snow, huge bank with the grader, and now there's a boulder of snow 3 feet high in front of the truck. I've had to drive around it. Very embarrassing as I've over-maintained this machine, and now who knows, maybe I caused this on my own, but I don't think so. I think the plugs that are inside that switch are actually worn, and it's leading to this. And luckily Badger 2.0 printed some new plugs for me, which I've got here 3D printed, so I might give those a try. Anyway, thanks for watching, and here we go. So here we are, the first contact on the left motion. We've got 2.1 ohms. So here we have the second contact on the left motion. So we see the resistance there, 3 ohms, so we're good. So here we're gonna try the first contact on the right. So here we are, we have 46 ohms. Here we have 45 ohms. We have 60 ohms. We have 65 ohms. Let's try the other contact. So I've tried the so-called the top ones. I try the bottom ones now. I've got little alligator clips. So here we have the other contacts to the right. And we have 7.5 ohms. So that's quite a lot better, but it's the contacts on the top of the switch near the connector that don't seem to be working right. So here we're good. So I've not tried this again, but the contact was 250 ohms, maybe off camera, 60 ohms, 60 ohms, 45 ohms. Now I see that it's 4.5 ohms. So if I try it to the right, oh, I can hear it. It wants to go, but it's not going. I'm gonna take that plug out again. So there, we've got 13 kiloohms, 8 kiloohms. Something's going on in there. We're not making. Here we got 540 ohms, 13 ohms. Something's up. And again, that's on the top. Whereas if I go back to those bottom contact, bottom, 3 ohms, 4 ohms, 2 ohms, 2 ohms, 2 ohms. So top contacts. So it's the top contacts. Let's get the switch out, get it apart. I'm gonna fast forward right to that because all this content is in episode 17. Here we go. All right, here we are on the bench. The switch is removed, and now we've got the alligator clips in the top left in the center position, and we've got the meter. So I'll read off the meter as I activate the switch. It's 120 ohms. Here we got 8. Let's go the other way a couple times. Now when I did this initially off camera, it was in the kiloohms, so it's not a very reliable thing. Something's going on in there. See, also, I'm getting a much more positive action when it's off, which is kind of that mechanism that's with the lever prevents it from doing. It's a lot more reliable now, but let's take it apart anyway and have a look. Now, there's nothing I love more than taking something apart I've already fixed. So what we're gonna do here, like I said in the last video, we're gonna take a tie wrap. All right, now that all the tie wraps are in, all right, here we go. So with a bit of squeeze in there, it's coming out. There we go. All right, so now we're gonna take those tie wraps out. Now we've got the contacts that have fallen inside, and we're going to take this apart. Right away I can see some burning on some of the contacts here, so that's going to lead to a higher resistance. So here we've got the pieces, the plugs from before with the springs inside. So we can see that they are worn a tiny bit. Now we go and check the contacts. We can tell that we've got some blackening again on the contacts, which I think we'd sanded that off last time. So we're going to try out some 3D printed parts from Badger 2.0. So side by side, it's a very, very close match. We've got one with a more flattened head and one with a more rounded head. So I'm going to take the flattened heads and move them. And I'm going to want to try these two rounded heads. So here I've got some nice rounded heads. I'll try to stick the springs inside. They fit, which is perfect. I'll put these plugs back in. So there we have the 3D printed plugs inside, which I think somebody else accomplished this with the tip of a Sharpie. Now these are the stock ones, which I think have worn a decent amount. We can move that to the side. The next step is going to be to sand these contacts to make sure we've got a really nice contact surface. And it wouldn't hurt to silver treat them as well, but I don't really have that. I might be able to put a little bit of solder on there actually. All right, so we're going to take the existing contacts and go on some super light grit sandpaper to try and get those points gone. And we don't want to use too much of it. We want to get just the majority of the black off. And again, there's a little black dot. We're going to get that off. Same thing here. We want to take these black dots off because they don't conduct very well. So we've got the black more or less off the contact points. Okay. We're now going to straighten out these tabs that appeared slightly bent. Try to actually move these tabs inward a tiny bit. Really not much, but just say inward a little bit, which might help the friction on the rockers. Gonna go again with some dielectric grease on the underside and the top side. And then what we can do is with the contacts like this, and we've got, it's keyed, so we're going to hold the switch center and the contacts installed. I'm going to push this up just gently. There we go. All right, so after putting the switch back together on camera there, I went with the multimeter on the back. Now remember, the center pins are the common for each direction, and then each side is where you want to check for continuity. So by putting the multimeter in the center of both directions and then using the exteriors, you can test. So here we see the switch has a fairly positive action both ways. It feels a little bit notchy, but I think it might help a little bit. So I'm going to get it reinstalled now, following the same instructions as episode 17. And we hope it's not flaky, because it's very annoying when the chute won't turn. Here we go. You know what grinds my gears? Lack of symmetry. Here we have the lever in the right position and the left. The right and the left. What do we see? Lack of symmetry. So if we push to the right and it doesn't go all the way and the contacts don't make, that could lead to contacts burning because they're barely touching. So I really want to make a small modification, is to increase the travel of this lever to make it symmetrical. So I'm going to attempt to do that by taking this pin out right now. So you want to use a nice size punch to get that out. So now what we're going to want to do is expand a little bit to let it go to the right some more. So we're going to I'm going to take a round file, and I'm going to file the inside, the downward part of here, and the top part of here. So I'm going to start by making a slight line with Sharpie on the edges I'd like to file. So what I'm going to do then is take this chainsaw file, stick it on the inside here. All right, so now what we can do is line this up and go side to side. And I think that it's a lot better. I'm gonna file it a tiny bit more just to make sure. Okay, after a final filing, I've got to this extreme, to this extreme, this extreme. So after a bit more filing, I've got this arrangement so that it goes as much to the right as it does to the left. Now I'm going to proceed to putting that pin back in there. Here we've got the pin. We can see it's tapered a little more so on the one side. The side I have not hit it on yet. So I'm going to maybe try to put it in there a little bit. Take this punch that's a little bit larger. Hope for the best here. All right, the pin is back in. All right, so what we're gonna do now is I've put the switch in and I'm gonna connect it. Before we go and put a whole mechanism back in, let's try it out. So I would suggest doing this a couple dozen times so that you can be sure that you don't do this whole job only to have it fail 3 uses later. Not that I would know what that feels like, of course. All right, so now that we confirm it works, I'm going to put the lever back in, same as episode 17. I'm not gonna film it again. Guys, there's nothing more than I hate than slop in a linkage. It's like a dirt bike throttle. If you've got slop in there, it means you're wasting lots of time trying to control something through empty air. No. So, although I showed it on episode 17, I'm going to show it again because Yamaha could have done better on this. This is loose enough that the slop that comes from there grinds my gears, and maybe it grinds yours too. So take a small bit of stainless steel wire and fish it through the hole and wrap it around. There's no particular order to this, but all you do then is make sure that the two move in unison. So when I move here, it moves together. When I move here, it moves together. Slop should never exist in a mechanism like this. All right, let's talk about root cause now. I firmly believe that this mechanism that didn't have the clearance to go all the way to the right would cause this switch to barely make its contacts, and contacts that barely make spark, they burn, and then the resistance goes up. That means they get hotter and they spark and they burn. So by expanding that rod with that chainsaw file, we now have full motion. And this problem I had spotted it in episode 17, but didn't fix it at that time. And that's on me, and now I suffer. So again, from this vantage point, we want to go as much to the left as we go to the right. In this case here, we might be going to the right just a tiny bit more, but you want to make sure you have the switch's full engagement here. All right, everybody, that wraps up episode 22. Really, thanks for watching. In a nutshell here, I think that the switch had developed some arcing on the contact. So we're able to sand that away and pick it away so it gets back to bare metal. And then bend the tabs of the contact casing there and put it back together. But then once we reassembled, I think it was important to just remount that the hole in that rod so that we can get full motion to the right as we did to the left. And if we can get full motion, it'll cause a switch to fully make its contacts instead of maybe just barely making and sparking when we're trying to make the motor go. So thanks for watching, like and subscribe, and we'll see you next time.